All right, so the main focus on chapter 6 is what we call systems of equations. Okay? And what that is two or more separate equations. For the most part, we really only deal with two. Every once in a while, you'll see one that's got three or more. Okay, but a systems of equations is going to be two or more separate equations. So what that looks like is something that looks like this, where you have one equation, y equals 3x plus 1, and then y equals 2x plus 7. Whatever, I just made those numbers up. Okay, but you get the idea. Okay, they don't always have to be in y equals. Okay, they don't always have to be x and y, but for the most part they will be. But that is essentially a system of an equation. And when we're asked to solve them, we are looking for a solution that fits both equations. Okay? Usually it's a point, right? It could be multiple points. It could be a whole bunch of different things. Okay, but usually it's a point like x and y. Again, not always, but definitely for what we're going to be doing in this first part, it will be. Okay, so let's take that first one that I just kind of made up, for example. Okay, the easy, or not the easiest, but the easy one way to solve this, and we're going to go through 3 different ways to solve them. Okay, the first one is going to be solve by graphing. Okay, pretty easy step process here. Step 1, graph both equations. Step 2, find point of intersection, and that's going to be our solution. Okay. So if you can't graph a line, that's not good. Okay, gonna have to fresh up on that a little bit. Okay, so I'm gonna graph, making x and y axes here. Okay, and so I'm graphing, again, I'm just picking the ones I wrote earlier, for example. So y equals 3x plus 1 and y equals 2x plus 7. Now I'm starting to regret picking those numbers, but that's okay. We'll see if we can make it work. Okay, so when we're graphing the first one, we start with our y-intercept of 1. So that's our first point. Okay, and we have a slope of 3. So it goes up 1, 2, 3, over 1, up 1, 2, 3, over 1. Okay, might have to extend this line if I'm being honest. Okay, so that's that first line. The second line here, 2x plus 7. So 1, 2, 3, 4, 5, 6, 7. Okay, and I have a slope of 2. So I go up 2 over 1 for each one of those. Okay. Again, I didn't pick a good graph because it goes up way up here. Okay, right in the middle of that G it looks like, and now I have to count, which I'm not looking forward to. So it goes right there. So my X value is 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 and a half. I'm kind of guessing because it goes through. It goes through there. Now I might have missed, my line might not have been straight enough. Okay, a whole bunch of different issues. Normally we wouldn't give you one that would intersect way up here. Okay. Let me try one on this next page. That'll be a little easier. Okay, so let's say we have a system, y equals 2x minus 3 and y equals negative 2x plus 1. Okay, this one should work out a little bit nicer. All right, so we're graphing the two lines and we're looking for where they intersect. So first one, y-intercept of negative 3, 2, 3. From there, it's a slope of 2, so up 2 over 1, up 2 over 1, up 2 over 1. Okay, my second equation has a y-intercept of 1. Okay, and a slope of negative 2, so I'm going up 2 to the left 1, up 2 to the left 1. Okay, this one definitely intersects at a much better place. Okay, point of intersection, obviously right there at 1, negative 1. Okay, and then you could always kind of go back and double check, right? We can plug these in and it should give us true statements. So if I plug these in for both of those systems, I get negative 1 equals 2 times 1 minus 3, which would give me negative 1 equals 2 minus 3, which is negative 1 equals negative 1. So that one checks out. And then I plug it into the second part of the system as well. Negative 1 equals negative 2 times 1 plus 1. Negative 1 equals negative 2 plus 1, which gives me negative 1 equals 1, which again checks out. So I know I graphed them correctly and I found the correct point. Okay, do another one. If you're trying to do this on non-graph paper, you're obviously going to struggle. So we graph this first one, y-intercept of 1, slope of 1. Graph the other one, negative 4, 1, 2, 3, 4. Slope of 3 up 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1. And this one isn't going to be pretty. Okay, whatever that point is would be the point of intersection. We'll try one more here. Let's watch. We'll do this one actually. Y equals 4, x equals -3. Okay, so if we have a graph that's y equals 4, it means we go to 4 on the y-axis, 1, 2, 3, 4. Okay, and that's just going to be a straight horizontal line because all of your y values on this line are going to be equal to 4. Okay, if you have x equals 3 and you're asked to graph it, you go where x is equal to 3. Okay, and that one's going to be a straight vertical line. Like so. So their point of intersection is right there at -3, 4. Okay, and we give you an equation and we ask you to graph it or solve by graphing. Obviously, the points should work out. We wouldn't give you something that looks like this, okay, because that's not likely. Okay, we'd give you something like this or something like the one above here where the point of intersection is right there at a nice point. All righty, so that is how you solve by graphing.